In this video, we are going to be solving systems of equations by graphing. Our objective will be to solve systems of linear equations by graphing and to be able to state whether these situations have one solution, many solutions, or no solution. Here is an example of a real-life problem where we could use graphing to find out when the cost of these two cell phone companies will be the same. And again, that's just one method of problem solving. We could make a table, we could make a chart, we could make a diagram. But if we were to make a graph, we could find out when the cost will be the same. We'll begin with Verizon. Verizon charges $40 a month and $5 per gigabyte of data. Then we will graph Sprint, which charges $25 a month and $10 per gigabyte of data. I've labeled the x-axis, counting by ones, with the gigabytes, and that is my x-axis. I now need to label the y-axis with my charge, which is in dollars, and we could probably go by fives on this scale since our charges are getting larger. This would be our y-axis. If we start with Verizon, they begin with a charge of $40 a month. Since that's our beginning charge, that's our y-intercept. And then they charge $5 for each gigabyte. So for 1 gigabyte, our total charge would be $45, 2 gigabytes 50, 3 55, 4 60, and so on. We'll draw a line to connect those points together. And now we will make a line that represents Sprint. Sprint begins at a charge of $25 for a month, and then in 1 gigabyte we add $10. So that gives us a charge of $35. In 2 gigabytes, that gives us a charge of $45, and so on. And we'll draw our line from there. After drawing in the line for Sprint, we can see that our lines cross at 3 gigabytes at $55. That's when the charge for Verizon and Sprint will be the same. We can apply this to many real-life practical applications, but let's first take a look at how we graph systems of equations. A system of equations is two or more lines that we are going to solve by graphing on the coordinate plane. The solution of the system could be one solution, and in one solution we would draw two lines on the coordinate plane that would meet at one point. For example, if I were to draw this line and then I were to draw another line, the one point where they meet, the point of intersection, is the solution to the system. Just like in our previous example, Verizon and Sprint met at one point, and at that particular point it was when the charge was the same for both companies. We also might have a situation where we draw two lines and they never meet. That means they are parallel and they have no solution. We also might have a situation where we have two lines, one being directly on top of the other, and that would mean that in this particular instance there are many or infinite solutions to the system. Let's take a look and practice some examples. In example A, we have two equations, y equals 2x minus 3 and y equals x minus 1. So when we graph, the first thing that we would like to do is to take a look at our first equation, y equals 2x minus 3, and we'll graph by using the y-intercept as our starting point. In this case, our y-intercept is at 0, negative 3. From there, we will graph the rest of the line using the slope. So we'll put a point at 0, negative 3 on the coordinate grid, and then we will use our slope. Our slope is positive 2, which means we're going to go up 2 and over 1, up 2 and over 1, and graph our line from there. It's a great idea once you have your line drawn, we ask that you please label that as y equals 2x minus 3 so we know which line goes with which. In our second line, we have y equals x minus 1. Our y-intercept is at 0, negative 1, and our slope is the coefficient of x. Since there isn't anything out front, we understand that it is 1, and our slope will go from there. So first we'll put our point at 0, negative 1 for our y-intercept, and then we will graph our slope, where we go up 1 and over 1, up 1 and over 1, and we will draw in our line. After you've drawn in your line, be sure to label it with its equation y equals x plus 5. In our second equation, we have y equals negative 4x. Notice there isn't anything being added or subtracted, so therefore, since there isn't anything there, we know that our y-intercept is at the origin 0, 0, and our slope is at negative 4. So we'll put our point at 0, 0, and our slope is negative 4 over 1, which means to go down 4 and over 1. Down 4 and over 1. And then draw in your line. Be sure to label your line after you have drawn it as y equals negative 4x, and be sure to extend it to fill up your graph. At this point, then, we can see where our two lines intersect, and that happens to be at the point negative 1, positive 4. That is our solution to our system of equations. Let's check. If we substitute the negative 1 for x and add 5, we get an answer of 4. And if we substitute the negative 1 into our second equation, negative 4 times negative 1 is positive 4. It is a solution to both. Let's take a look at our next example. We have y equals 3. Y equals 3 we know is a horizontal line at positive 3. So let's graph that. And let's label that line as y equals 3. Our other equation, x equals negative 2, we recognize as being a vertical line. So let's draw our line on the x value at negative 2. Be sure to label your line x equals negative 2. And then we're looking for the point of intersection where the two lines cross. This is at the point negative 2, positive 3. Now there's really nothing to plug in necessarily, but what we do know is the y value needs to be 3 and the x value needs to be negative 2. And that creates the solution to the system, which is our point of intersection. Let's take a look at the next one. We have y equals negative x plus 1. Our y-intercept is at the point 0, 1, and our slope is at negative 1. We'll put our point at positive 1, and our slope being negative 1 means down 1 over 1, down 1 over 1. We'll draw on our line. Be sure to label your line y equals negative x plus 1. Our second line is at y equals negative x minus 1. Our y-intercept is at the point 0, negative 1, and our slope is negative 1. We'll put our y-intercept at negative 1, and then our next point we'll use our slope, which is negative 1, so we'll down 1 and over 1, down 1 over 1, and we'll draw our line. After we finish drawing our line, we need to be sure to label it as y equals negative x minus 1. And what we should notice is that the lines are parallel. And since they are parallel, they have no solution or no points in common. So the solution to this system is no solution. Notice that we could have found that out to check is that the slopes are the same. And when the lines have the same slope, they are parallel. Let's take a look at our next example. In our first equation, we need to make sure that it's written correctly in slope-intercept form. Right now it's -1 minus 1/4 x. Since these two values are on the same side of the equation, we simply need to just reverse their order to put it into y equals mx plus b. Our y-intercept is at the point 0, -1, and our slope is at the point -1/4. So we'll put a point at -1, and then using our slope, we're going to go down 1 and over 4, down 1 and over 4, and we'll draw on our line. We'll label our line y equals -1/4 x minus 1. Notice that the second equation is exactly the same. So in this case, these are exactly the same line, and so we have infinite solutions, meaning no matter what point we pick, it will work in both of these lines because they are the same. To review, you are finding the point of intersection of two lines. The lines may intersect at one point, which means there is one solution. The two lines may be parallel, which means they would not intersect, and that would be no solution. Or the lines may be the same line, and therefore many or infinite solutions. Please complete the reflection.